All right, let's talk about something you use every single day but probably never see. It's this invisible engine that basically runs our entire secure digital world. It's called hashing. And yeah, it's a secret sauce behind everything from Bitcoin to just logging into your email. We're going to break down exactly how it works.
So what if every single file, every message, every password you've ever used had its own unique, unforgeable digital fingerprint? I mean, really think about that. It sounds like something out of a sci-fi movie, right? But it's not. That's exactly what hashing is all about. And it's pretty much the foundation for how we build trust and security online.
Okay, so I keep using this term digital fingerprint. Let's really dig in and figure out what is a hash anyway. Okay, so at its heart, hashing is basically a transformation process. You can take literally any input, a simple word, the entire text of a novel, a massive image file, you name it, and you feed it into this special mathematical algorithm, which we call a hash function. And what pops out on the other side? A totally unique string of characters that's always the same length. And that output, that's the hash. That's the data's fingerprint. And here's where it gets really, really cool. I mean, look at this. The process is so incredibly sensitive. The only difference between these two inputs is one single capital letter. That's it. But look at the fingerprints that come out. They're completely different. There's no resemblance whatsoever. This is a super important feature and has a great name, the Avalanche Effect. And this is exactly why it's so easy to spot when someone's been messing with data. Now, you can't just use any old algorithm to make a secure fingerprint. Oh no. A really good hash function, like SHA-256, which is famous from Bitcoin, has to follow some pretty strict rules. For one, it's got to be deterministic. The same input always gives you the same output, every single time. It also needs to be super fast. But the most critical part? It absolutely has to be a one-way street. You can't reverse engineer the original data from the hash. And it should be practically impossible for two different inputs to ever end up with the same fingerprint. You know, that one-way street idea is so important. We should really spend a second on it, because this is the key thing that separates hashing from another word you've probably heard a million times, encryption. People get them mixed up all the time, but honestly, they're designed to do totally different jobs. Okay, think about it like this. Encryption, that's like locking something in a safe. If you've got the key, you can open the safe and get your stuff back, right? It's a two-way street, and it's all about keeping things secret. Now hashing, that's more like taking that same thing and throwing it into a blender. You get this unique goop at the end, but there is no way on earth you're turning that goop back into what you started with. It's not about secrecy, it's all about verifying that something is what it says it is. It's about integrity. And that unique, one-way, blender-like property? Well, that is precisely what makes hashing the absolute backbone of the most famous decentralized tech we've got, the blockchain. So how does this all fit together? Well, picture each block in a blockchain as like a page in a digital notebook. Once that page is filled with transactions, you seal it with its own unique hash, its own fingerprint. Now, when you start the next page, block 2, you don't just write down new transactions. The very first thing you do is write down the hash from block 1. And by doing that, you create this super strong cryptographic link. And boom, you've started to form the chain. Okay, and this right here, this is where the genius security of the blockchain really shines. Let's say a bad actor tries to go back and change a transaction in an old block. What happens? Well, remember that avalanche effect we talked about? The tiniest change means the hash of that block completely changes, and that instantly breaks the entire chain because the next block is now pointing to a hash that doesn't exist anymore. The whole network sees this and immediately flags it as invalid. It's just rejected, and that makes the whole ledger basically tamper-proof. But wait, there's more. Hashing is also used inside each block in this really clever way, using something called a Merkle tree. So instead of just hashing all the transaction data in one big blob, each individual transaction gets its own hash. Then you pair those hashes up and hash them together. Then you take those new hashes, pair them up, and hash them again. You keep doing this until you're left with just one single hash at the very top. That final hash is called the Merkle root, and it's like a master fingerprint for every single transaction in that block. And this is so efficient. It means you can quickly check if one specific transaction is in that block without needing to download and sift through everything. Okay, so at this point, you might be thinking, this is all cool crypto stuff, but what does it have to do with me? Well, hashing isn't just for blockchain wizards. You are literally interacting with this technology every single day, and you probably don't even know it. Think about it. Every time you log into a website, that's hashing. The site doesn't actually store your password, or at least it shouldn't. What it stores is a hash of your password. So when you type your password to log in, the system hashes what you just typed and simply compares the two fingerprints. If they match, you're in. And why is this so great? It means that even if hackers break in and steal the user database, they don't get your password. They just get a bunch of useless gibberish. The same idea is at work when you download a big file and your computer checks to make sure it wasn't corrupted, or when you use a digital signature on a document. It's all hashing, working silently in the background. All right, so let's pull all these threads together. Why does any of this matter? Why is the simple idea of a one-way digital fingerprint so incredibly important today? You know, this quote here really just nails it. Hashing is the magic that lets us prove that data is authentic, that it hasn't been changed, without needing some big central authority like a bank or a government to give it the stamp of approval. It's the engine that powers trust in decentralized systems like Bitcoin, and it's the simple, elegant lock that keeps our daily logins secure. When you really think about it, hashing gives us this beautifully simple answer to a really complex problem. How do you trust anything in a digital world where everything can be copied and changed in a blink of an eye? Hashing is that silent guardian, that invisible engine of trust, which kind of leaves us with a pretty big question, doesn't it? Now that we have this incredible tool, what's the next huge problem we're going to solve with it? Thanks so much for tuning in.